Okay, if you've learned a little bit about psychology, you've probably at least heard terms like classical conditioning or operant conditioning, though these are easy to mix up, and you've probably heard terms like positive reinforcement that are associated with conditioning, although you might be a little vague on what, the different terms, punishment and reinforcement things are. But what do we mean by conditioning? Basically, we're just talking about the processes, the mechanisms by which learning occurs. That relatively lasting change in behavior, it can happen a few different ways. So things like classical conditioning or operant conditioning, they just delineate a couple of the most common ways that learning or conditioning occurs. So, as I said before, behavior analysts, or the field of behavior analysis, uses kind of its own terminology, some terms and notation that we'll just get used to as the course proceeds. For example, the first type of conditioning that we'll dive into is going to be the big topic following these introductory videos. It's what we call respondent conditioning. This is actually just the same thing as classical conditioning, or you may have heard it called Pavlovian conditioning after Ivan Pavlov. They are all talking about the same process. That process goes like this. Take some existing reflex, so something kind of you're born with as whatever species you are, some existing reflex where a stimulus, we'll put that as an S, a stimulus S, reliably elicits or pulls out a response R. So we could write that reflex as S arrow R, like you can see here. Stimulus leads to response. In other words, a stimulus, something out there in the environment, leads to a behavior. Response meaning a behavior that you or the organism does. Okay? That, what we'll do then is respondent conditioning would be taking that reflex and pairing up some new neutral stimulus with that first stimulus that's part of the reflex, pairing them up over and over and over again until that new stimulus starts to elicit its own response, makes a behavior happen that didn't used to happen to that new stimulus. That is the process, the mechanism of respondent conditioning or classical conditioning. So fundamentally, it's powered by stimulus-stimulus pairings. In other words, the fact that a thing shows up consistently with some other thing in the environment, in our experience. And the brain starts to associate those two things. The brain makes a connection or an association between two stimuli, S and S, and that's what drives this kind of learning. That's what drives respondent conditioning. Now, the reason we'll call this respondent conditioning is because that behavior, the behavior that gets elicited by the stimulus, is actually called a respondent. You might see it called a respondent behavior. Same thing here. A respondent just means the stereotypical response, the stereotypical behavior, for example, salivating or drooling, that's evoked automatically by a prior stimulus, like smelling delicious food cooking or smelling some cookies baking or something like that. Now, sometimes we distinguish an unconditioned or unlearned response, so a UR, meaning a response that you're born with, one that doesn't require any learning or conditioning. We might distinguish that from a conditioned or learned response, a CR, a conditioned response, which would mean a response you picked up through learning, through experience, through the conditioning process of respondent conditioning. We'll actually come back later to that terminology. You may have seen it in an intro psychology course or something before. We'll come back to that stuff later, so don't get too hung up on it right now. I just want to point out this type of conditioning. Now, despite the terminology, you're probably already at least vaguely familiar with the idea behind this, because this is the kind of learning that Ivan Pavlov discovered in dogs. He noticed an existing reflex where food would lead to salivation behavior. In other words, some meat in front of the dog leads to the dog drooling. That's a reflex. The meat is a stimulus. It's something the dog can kind of see or smell or hear or taste, right? And then the drooling is a behavior or response in the dog. It's something the dog does as a response to that. So it starts with an existing SR relationship, stimulus-response relationship. That's the reflex that already exists, right? So we'd say it's an unconditioned or unlearned stimulus. You don't have to learn to like food. The dogs are born with that reflex to it. And an unlearned or automatic response. So a UR to that, right? Then Pavlov found that he could make a sound like ringing a bell or something similar prior to bringing the meat each day. So he is pairing up two stimuli. What he did is ring the bell, then bring the food. Ring the bell, then bring the food. So that's an SS pairing, a stimulus pairing. And he paired that bell with the meat over and over and over again, and found eventually the dogs started to salivate, in other words, have a behavior, a response, an R, when they heard the bell, even before any meat showed up. That's not something dogs do naturally. It is a learned behavior, a conditioned behavior, meaning one caused by this whole conditioning process. So at the end, we might call the bell a conditioned stimulus, a stimulus that has some conditioning or learning that has now happened. And then the salivating that happens after it, that's a conditioned response, meaning a learned response. And that behavior, the salivating, we would call a respondent behavior. That process, which Pavlov articulated, he studied it a lot, he described it really well. He even repeated it in children and orphans. It's really kind of messed up. But that process is respondent conditioning. And we'll dive really deeply into that in the next big topic of the semester. Okay, the other major type of conditioning, and the one we'll spend the most time on in this course, is operant conditioning. This is a fundamentally different type of learning because the focus is on what happens after we do a response. In other words, after we do a behavior. It's the consequences of doing that thing that will lead to the learning and the regulation of future behavior. So the focus here in operant conditioning is on an RS relationship, where a behavior R, right? We used R for response before. You can think of that as just a behavior, something you do as a creature. A behavior R leads to a stimulus happening, a consequence, something happening out in the environment. So the behavior an organism does, we'll always, in this course, we're always going to represent it with an R just to keep things simpler, because we use that for respondent conditioning. So whether we talk about respondent or operant, the behavior, the thing the creature does, will always be an R. If you see an R, just think behavior. Behavior leads to stimulus. S will always mean stimulus, some event or object out in the world, something you can see or smell or taste or hear, something that occurs, okay? So, for example, operant conditioning is the kind of thing that would be at play when the sitting behavior of a dog leads to a yummy treat stimulus as a consequence, or when the swiping right behavior of a Tinder user produces mating opportunities as a consequence. In respondent conditioning, we said that behavior was elicited. It's a way of saying it's kind of automatically pulled out. It's forced out, almost reflex-like, but a learned reflex, right? In respondent conditioning, the stimulus makes you do that behavior. But operant conditioning is fundamentally different. So in operant conditioning, we say the behavior is emitted rather than elicited. Sometimes the creature does the behavior, sometimes it doesn't do the behavior. It might be a little more probabilistic. But regardless, when the creature happens to emit the behavior R, something happens as a consequence. The behavior here, the R, it's called an operant. Rather than calling it a respondent behavior, we call it an operant behavior, or an operant. That's just to help us keep track and distinguish from the behavior R that might show up in respondent conditioning. That's a respondent. If it's elicited by a stimulus in respondent conditioning, it's an operant when we're talking about operant conditioning process where the behavior leads to something as an outcome. Basically, an operant just means a behavior that causes a consequence or effect, that operates on the environment. That consequence, the result we observe after doing a given behavior, is itself a stimulus, is an S. Sometimes we'll add a little superscript, a little, upper little small r there to make it an SR if it's, for example, a reinforcing stimulus, a stimulus that reinforces or increases the behavior in the future. But we could also put something up there like a little superscript P after the stimulus if it happens to be that the behavior leads to some stimulus that we don't like that might act as a punisher. So we'd put a little S with a superscript P to say it's a punishing stimulus, a stimulus we don't like that makes the behavior less likely, something like that. Don't worry, we're going to come back and clarify all these terms when we dive into the nitty-gritty in future topics. This is really just a quick and dirty introduction to those terms that we're going to start using more soon. So, okay. Fundamentally, operant conditioning is about that R-S relationship. Emitting a behavior R leads to a stimulus S afterwards in a sort of consistent or predictable way. But often the consequence of a behavior, whatever happens after it, depends a little on the situation or context that we're in that moment, right? So rather than just denoting the process as R leads to S, we'll often write this. The S with a superscript D, and then a colon, and then that relationship where the behavior predictably leads to a stimulus. So the big S at the start here, that just means stimulus. It'll always mean, big S always means stimulus. But now we've got that superscript D up there. That's telling us what type of stimulus it is, what function a stimulus happens to be serving in this context. So the SD at the start of our little equation here is called a discriminative stimulus. We say the discriminative stimulus sets the occasion for a behavior R to produce a consequence. So the colon here could be pronounced as sets the occasion for, but in essence, all this little bit of notation here is saying is this stimulus occurs in the environment. When the stimulus is happening, it tells me that this relationship is active. It tells me when this discriminative stimulus is present, it tells me that if I produce a particular behavior right now, it'll reliably lead to a particular stimulus as a result. We're just formalizing that with some shorthand notation here so we can refer to these elements in all sorts of specific examples in the future. So we'll get more used to using it over time. Now, as a side note, you might also see some other stimulus notation at the front here, like instead of an S with a big D for discriminative stimulus, you might see an S with a little triangle up there, a Greek delta symbol. So S delta is a stimulus that might signal a context where the behavior R will do nothing, where the behavior R won't lead to the consequence that we want. So, for example, when a restaurant window has a big-ass closed sign on it, that is a stimulus which tells us that the normal behavior of pulling on the door handle will probably not lead to the stimulus of getting some yummy food. Whereas, if there's a big open sign on the door or on the restaurant window, that can serve as a discriminative stimulus, as an SD, telling me that the behavior of pulling on the door handle will probably reliably lead to some yummy food as an outcome. So you can think of this as a sort of environmental stimulus, an environmental hint about what contingencies are active right now, what possibilities are active, what certain behaviors will lead to in this time based on our past learning. But this is going to be part of the equation we'll want to pay attention to, is these signals in the environment that tell us when certain behaviors will work or not, or what stimuli they'll lead to in certain circumstances. So we can study this kind of learning, the changing of behavior based on consequences, in a laboratory. For example, we might put a little rat in a testing chamber like you can see here. We might set it up so that when a light bulb is on, there's a little light in the chamber. When that light bulb is on, it could serve as a signal to the rat that the rat can press the lever to get food. So in that case, the light is a discriminative stimulus, an SD, setting the occasion for this setup, setting the occasion for this contingency where the behavior of lever pressing will lead to the stimulus of food as a consequence in this example. But the same kind of thing is actually at play in all sorts of day-to-day human behaviors and human learning outside of the laboratory too. For example, a little baby's behavior can be affected by its mom's reaction to the kid's behavior. For example, maybe when a baby smiles, he gets attention or even gets picked up by mom, right? That's something the baby might enjoy. We could say, for this baby, smiling is the behavior, R, right? We use R for the behavior. Smiling is the behavior. Getting picked up is the stimulus, something that happens to the baby, the event that happens as a consequence of that smiling behavior. But specifically, there might be something in the environment that signals to the baby, based on past experience, that right now the smiling behavior will lead to being picked up. It might be as simple as seeing mom or even just seeing a human face, but basically this reliable signal, this discriminative stimulus, sets the occasion for that baby's smiling behavior. It tells the baby this is when smiling will lead to getting picked up as a consequence based on my past experience. Okay? Another way to think of it is the discriminative stimulus just means a setting or a context or a situation where the behavior R has previously led to a consequence S. So what about when the SD isn't present, when the discriminative stimulus, the signal isn't there, or a different signal is there that's kind of our S delta telling us no. So for example, when the light is off in that rat's cage, or if there's no human face present in the baby's environment, then what's going on? Well, notice that doing the behavior in this case is going to lead to nothing. The stimulus doesn't show up after the behavior. So if that S delta is present, or the discriminative stimulus of the light isn't on, then the lever pressing behavior doesn't lead to food. Press the lever, no food comes out. Or the baby smiles, but no one picks him up. That means in this circumstance, in this situation, the behavior isn't going to get reinforced. It's not going to get rewarded, basically. So eventually it won't be emitted when the discriminative stimulus, the light or the human face, isn't present anymore. So the rat will learn not to press the lever when the light is off. The baby will learn not to smile as much when there's no human face around. The probability of those behaviors, like lever pressing or smiling, changes based on the consequences, the food and the picking up. But notice that we're also learning, in operant conditioning, we're also learning about the context for those relationships, the discriminative stimulus, the SD, or in those latter examples, the S delta, right? Like a light being off. Note that, like I said, the discriminative stimulus in operant conditioning does not force or automatically elicit the behavior R. It just changes the probability of R being emitted. And that discriminative stimulus, that SD, it only affects the probability of R after we've had experience, after a history of consequences happening as a result of that behavior R in that context. So this language of eliciting a behavior versus emitting a behavior, it's very deliberate. It's to help distinguish these two learning processes that are very different, these two types of conditioning. In respondent conditioning, the stimulus basically forces the behavior, kind of like your brain has learned a new reflex and it's not under your control. But in operant conditioning, it's about behavior that is sort of naturally emitted that happens to have consequences in certain contexts, which over time make that behavior more or less likely in the future in that particular context. And we will be able to discriminate, to tell the difference between different contexts or different situations where different behavioral outcomes might occur for our behavior choices. Now, just to give us a little breather from all the terminology, here's a quick little clip of what you can do using the principles of operant conditioning, like teaching some birds to play basketball. So we could say the behavior R is putting the ball through the basket. And the consequence, as you can see, the consequence for these birds, the stimulus that shows up later, is getting a yummy treat. So that's a stimulus S that happens as a consequence. When they've been in the context of this table, right? So when they're in the right context, when the discriminative stimulus of the table and these pieces are present, then they know that seeing the table and the basket serves as an SD, reminds their brain, oh, this is when the dunking behavior leads to a treat. Rewarding them this way enough, they'll start doing the dunking behavior more often. Their behavior has changed as a result of experience, so we'd say they've learned to dunk or play basketball. Okay, for this video, one last bit of terminology I want to talk about, one last bit of complexity to our operant conditioning model before we finish the video and get on to some easier stuff. The last thing I want to discuss is called motivational operations, MO, which is basically any event or stimulus or operation thing we can do that alters the effectiveness of consequences and thus changes the frequency of a behavior. Okay, what? Let me clarify. So look inside the brackets here in this thing at the top. Look inside these square brackets and you've got the stuff we already talked about for operant conditioning. When the light is on for our rat, that's a discriminative stimulus telling the rat's brain that doing the lever pressing behavior R will lead to the food stimulus S, which is reinforcing for rats. They like food. So we might even write it as an S with a little superscript R up there, right? It's a stimulus that's reinforcing that'll make the R behavior, the lever pressing behavior, more likely in the future. Cool. So that stuff in brackets should kind of start making sense right now. But consider the fact that in some circumstances, the treat or the little food pellets might not be so yummy for the rat, might not be quite as rewarding as usual, and thus in those circumstances might not actually make the rat more likely to press the lever in the future. For example, if the rat is already super full and has a food baby in its little rat belly, then getting food pellets for pressing the lever won't really be very reinforcing. Indeed, it won't necessarily make the rat more likely to press the lever in the future. So we could say that becoming full, satiated, or being made full, that's a motivational operation. That's an MO that has a sort of meta effect on the operant conditioning process. Your motivational state matters for your learning. That's what this is saying. So to be a little more concrete, if you say withhold food from your kid, make them hungry, or if you've just been busy all day and not eaten, then that hunger will make food rewards, like giving someone M&Ms as a reward. It'll make those M&Ms work better as a reinforcer. They'll make a better reward if you make someone hungry first as a motivating operation. Likewise, that means that if someone is hungry or if you've withheld their food for a while, that's going to make them do the behavior more, do the behavior that in this context in the past has gotten them some damn M&Ms. So all it's saying is that when your motivation for the reward is high, you'll do the behavior that you know gets you that reward. But if your motivation is low, if we've done some operation to decrease your motivation, you won't necessarily do that behavior as much. That's the part of the definition here, changing the frequency of the behavior. When your motivation is low, the behavior shows up less because you don't need the reward as much or you don't care about the reward as much. So of course the behavior won't show up as much. In other words, another way to look at this, if you usually give your spouse M&Ms for doing the dishes, which, yeah, that's a great idea. You want your spouse to do the dishes more, just offer them a treat afterwards, right? They totally won't find that patronizing. But what if you do that, if you're doing that situation, a hungry spouse is going to be more likely to wash the dishes. And when they get those M&Ms as a reinforcer afterward, that'll really reinforce the dish cleaning behavior. It'll work really well as a reward. The reason we say motivational operation instead of just motivation is that in experiments, we're often talking about things we can do, like operations the experimenter can do to change motivation in this way. For example, my little rat in the cage, if I'm going to study it, I could not give it its dinner until after it does the experiment, make it hungry, and then food acts as a better reward, a better reinforcer for it. That would be increasing motivation. I'm not saying it's an ethical thing to do, but I'm just saying like that's an example. That would be an example of a motivational operation. But of course, the same principle applies to events or stimuli and things that might exist naturally and affect our motivation. We'll actually see that's much more common for a lot of the things we learn. Now, there are two types of motivational operations. You can make someone more motivated to do the behavior or less motivated to do the behavior, in other words. What we mean is that some operations will increase the effectiveness of a reinforcer, make the behavior more likely, while others will have the opposite effect. So we're going to call it an establishing operation if it makes the reinforcer work better and the behavior more likely. But we'll call it an abolishing operation if it decreases the effectiveness of the reinforcer and decreases the behavior. A nice simple example of an abolishing operation would be when someone's about to eat their breakfast cereal, you show them a video of vomit or gore. Showing that gross video will likely be an abolishing operation for their eating behavior. It'll actually make the food taste less rewarding when they do take a bite, and it'll probably decrease the odds of them doing the behavior of taking a bite. It decreases the probability of the behavior. You can think of it as something that abolishes your motivation or lowers your motivation. So maybe a last couple of examples, going back to the M&Ms thing. Imagine you usually give M&Ms for doing various chores, and you really want the dishes done at the end of the day. If you withhold M&Ms all day until the end, so a sort of food deprivation or M&M deprivation, make them really not have many, then M&Ms will probably serve as a great reinforcer at the end of the day. Them being hungry and M&M starved would be an establishing operation. But what if instead you've been giving them M&Ms left and right all day long, or maybe they've been sneaking M&Ms all day already? In that case, M&Ms are going to be a weaker reinforcer for dishes at the end of the day. They're not as good of a reward. And then that means the dishwashing behavior might be half-assed or less likely because the M&Ms don't work as well. So them getting full and satiated on M&Ms earlier in the day, that would be an abolishing operation. That's the idea of motivational operations. All right, well, in this video here, I know it was a lot of terminology all at once, but we'll go back through these ideas and dive into them in more detail with many more examples when we cover respondent conditioning and when we cover operant conditioning in future videos. For now, though, we've got a couple more little introductory videos to set the stage for the whole course. And the next little video will be an ever so brief peek at some of the history of learning as a field in psychology.